Good afternoon, class. We are looking at Chapter 8, Further Applications of Trigonometric Functions. Here's Section 8.5, Polar Form of Complex Numbers, the Complex Plane, De Moivre's Theorem. So we've covered the law of sine, the law of cosine, polar coordinates equations, and graphs, and now polar forms of complex numbers, the complex plane, De Moivre's theorem. The objectives are: plot points in the complex plane, convert a complex number between rectangular form and polar form, find products and quotients of complex numbers in polar form, use De Moivre's theorem, find complex roots. Reminding everyone of having a unit circle, x squared plus y squared equals 1. A point with coordinates x comma y is also cosine theta sine theta. Circle centered at 0, 0 has the formula x squared plus y squared equals r squared. Centered at h and k, x minus h quantity squared plus y minus k quantity squared. We've seen these fundamental identities many times over. I hope everybody is very comfortable with them. Pythagorean identities, quotient identities, reciprocal identities. Even and odd properties, all trigonometric functions are odd except cosine and therefore secant. In the case of a right triangle, Pythagorean theorem says a squared plus b squared equals c squared, and the two angles A and B must add up to 90 degrees because the total interior angle must be 180. Sine law, sine A over A equals sine B over B equals sine C over C. Cosine law, A squared equals B squared plus C squared minus 2BC cosine A. If you move things around, 2BC cosine A becomes B squared plus C squared minus A squared. If you divide by 2BC, you get cosine A. Polar coordinates. Here's the summary: plot points using polar coordinates. We have a Cartesian coordinate system and polar coordinate system, x and y, and the positive side of the x-axis, the polar axis, and the origin is the pole. A point P has coordinates x comma y, also r comma theta. So rectangular is x comma y, polar is r comma theta. Relationship: x and y. So x squared and y squared, they add up to r squared. Tan of theta is y over x. And of course, you adjust for the quadrant. Polar is r comma theta. Rectangular is x comma y, where x, remember, x is r cosine theta and y is r sine theta because sine of theta is the opposite y over r and cosine is the adjacent x over. A polar in the form of r comma theta can be represented as r comma theta plus 2k pi. This is negative. If you want to make it, there are infinitely many ways of representing it. So add 2k pi. If you want r to be negative, you have to add odd multiples of pi. Rectangular and polar grids. You have a point, 1 to the right, 2 up, 3 to the left, 1 up. But what about polar? You first find the angle, in this case, power 4, and then 2, you go 2 tick marks. The way we have it, each tick mark represents a circle. Circle of center, all of them centered at 0, 0 with the radius 1, then radius 2, so on and so on. So you want 4 comma 5 power 4. First, you locate 5 power 4, and then you go 4 tick marks or 4 circles. And putting them together, this is another grid which has both of them and shows how to locate points. Finally, note pole, which has coordinates r comma theta. As long as r is 0, theta can be any angle that represents a pole, represents the pole. What about the graphs? Refresh everyone's memory. When theta is equal to alpha, that represents a line that goes through the origin, y equals tan alpha times x. When r equals a, that's a circle centered at the pole or 0, 0. So r equals a is the same as x squared plus y squared equals a squared. When r cosine theta is a constant, that represents a vertical line x equals a. When r sine theta equals a constant b, y equals b, it's a horizontal line. And in all of these cases, meaning when r is plus minus 2a cosine theta or plus minus 2a sine theta, it represents a circle with radius a. All of them have radius a. If it involves cosine, then the center is along the x-axis. If involves sine, it's along the y-axis. Okay. And we have more graphs. Cardioid is in the form of a plus minus a sine theta or a plus minus a cosine theta. A plus minus b cosine theta or sine theta. They give us lemma without inner loop or with inner loop, depending on the value of a and b, which one is larger. And the rows, a sine n theta and a cosine n theta. So if it happened to be an odd number, we have the same number of petals. If it's even, you multiply it by 2. And again, plotting points will always do the job. And now 8.5, the complex plane, the Moivre's theorem. I'm going to give you the summary, and then we're going to elaborate. A complex number, everybody remembers we normally use a plus bi. It's the same thing, x plus yi or a plus bi, where x and y are real numbers. I is square root of -1 is an imaginary number. And we remember I is square root of -1. I squared is -1. I cubed is -I. And I to the power of 4 is 1. We should know that. The magnitude or modulus of z is the distance from the origin to the point x comma y. We represented in this format, looks like an absolute value, square root of x squared plus y squared, or the distance r. So here's the complex number, z equals x plus yi. Its conjugate or complex conjugate is x minus yi. Its modulus or magnitude is r, or square root of x squared plus y squared. It can be shown that it's z bar. And again, z bar represents the complex conjugate. And I remind you that a plus bi times a minus bi is a squared plus b squared. Again, recall a plus b times a minus b is a squared minus b squared. If we have a plus bi times a minus bi, the answer is a squared minus b squared I squared, which makes it a squared plus b squared, because I squared is negative. So this is the synopsis of the section. We're going to continue. X equals r cosine theta. Y equals r sine theta, just like the polar form. If r is greater than or equal to 0, theta is between 0 and 2 pi. Complex number in polar form has this format, x plus yi. This is called the standard form or rectangular form. R cosine theta plus I r sine theta is the polar form. Now, shorthand notation r cis theta, because c stands for cosine, I is I, and S stands for sine. Here's a complex plane. This is the x-axis, which becomes the real axis, is the y-axis, which becomes the imaginary axis. Z is x plus yi, or r cosine theta plus I sine theta. R is positive, could be 0, and theta is between 0 and 2 pi. And this distance r is the magnitude or the modulus, and that is square root of x squared plus y squared. Again, just a synopsis of what we, and tan theta, as always, is y over x, and you, if need be, you adjust for the quadrant. Z equals r cis theta. It can be shown that it's r e to the power of I theta. Go ahead, Lou, you have a question?
Is that supposed to say under the complex number in polar form? At the end of the equation, is that meant to say r cosine theta?
You talk about here?
Yeah,
It's the shorthand notation.
got it. Okay.
R cis theta. See, it's r cosine theta plus I r sine theta. The shorthand notation
Oh, I see.
uses this, which has the r, C stands for cosine, I, S stands for sine, and then R cis theta. This is a fast way of writing this one. This
This
means
whole
this.
equation. Got it. Okay, thank you.
Sure. All right. Again, this is the summary. Let Z sub 1 be R1 cis theta 1. That means R1 cosine theta 1 plus I sine theta 1. And Z sub 2 be R sub 2 cosine theta 2 plus I sine theta 2. So the shorthand notation would be R1 cis theta 1. For this one, R2 cis theta 2. Let me write that so you see it's a shorthand notation. For this one would be R1 cis theta 1. For this one would be R2 cis theta 2. This is a shorthand notation. Now, if you want to multiply Z1 by Z2, it is very easy to use the polar format. All you have to do, multiply R1 and R2, and then you use cosine and I sine. Now you add up the arguments theta 1 and theta 2. So you get R1, R2, cosine of theta 1 plus theta 2, plus I sine of theta 1 plus theta 2. And here's the shorthand notation. Z1, Z2 would be R1, R2 cis theta 1 plus theta 2. That makes it really nice and easy. All you have to do, add up the arguments. You multiply these two, of course. And if you want to divide them, Z1 divided by Z2, it's R1 over R2. Now, the argument would be the difference of cosine of theta minus 1 minus theta 2 plus I sine of theta 1 minus theta 2. And again, the shorthand notation, R1 over R2 cis theta 1 minus theta 2. The Moore's theorem says if you want to raise the z to the power of n, where n is larger than or equal to 1, raise r to the power of n, and then multiply the argument by n. So z to the power of n is r to the power of n cis n theta. What about roots? If w is r cosine of theta 0 plus I sine of theta 0, and n is larger than or equal to 2, there are n distinct complex nth roots of w. And we write it as z sub k is the nth root of r cis theta 0 divided by n plus 2k pi divided by n, and k is from 0 to n minus 1, 2k pi or 360 degrees times k. We are going to look at each and every one of the cases here. This is the synopsis of the entire section. All right, let's get started. Example 1, writing complex numbers in polar form. Plot and write complex numbers equals square root of 3 minus I. Reminding you that z is r cis theta, shorthand notation. R squared is x squared plus y squared. Tan theta is y over x. First and foremost, to plot this, I want to remind you of something we already know. For example, if it's 3 plus 2i, you go 3 to the right, 2 up. So if it's a plus bi, you go a to the right, b up. So minus 4 plus 3i, you go 4 to the left, 3 up. Now we want to graph this. So we go square root of 3 to the right. Square root of 3 is about 1.7. Minus 1i, so 1 down. So this is the location. So square root of 3, or about 1.7 to the right, and then 1 down because this is minus 1i. So that's, as far as plotting the point is concerned, it's very simple. To write it in polar format, we need r cis theta. So we need the r, we need the theta, and r is square root of x squared plus y squared. So we're going to square this number. Plus, we're going to square negative 1 under the radical. This is 3. This is 1. They add up to 4. And as you know, square root of 4 is 2. Tan of theta is y over x or b over a, sometimes they call it, because if you go with a plus bi. So let me just write that. Plus z is x plus iy or a plus bi. And so tan theta could be b over a, depending upon how you write. Anyways, y over x. So what is y? The coefficient of this, which is minus 1 over this, which is square root of 3. Negative 1 over square root of 3, I can rationalize it. And I get minus square root of 3 over 3. And we should recognize the quadrant is the fourth quadrant. And to understand the angle, I'm going to remind you that if tan theta was positive square root of 3 over 3, then theta would be pi over 6. And now which is negative? It's negative pi over 6. Negative pi over 6. Negative pi over 6 is the same as 11 pi over 6. So it's the same as negative pi over 6. Okay. If you want to go with positive, we put it that way. So z equals r cis theta. Replace the r with 2. Cis theta, replace the theta with 11 pi over 6. Again, you can write it like this, or you can write it 2 cis 11 pi over 6. It makes no difference. When you answer it for your homework assignments and exam, just answer the way they ask you, okay? The way they want you to answer. They may ask you for this or this. All right, plotting a point in the complex plane and converting from polar to rectangular form. We have z equals 2 cis 30 degrees or cosine of 30 degrees plus I sine of 30 degrees. So you have the grid. You make up 30 degrees angle, and then you go 2 tick marks. That would be the length of R. R is 2. It's not about X or Y, okay? So this is a 30-degree angle, and this is the distance of 2. R equals 2. Now, as you know, cosine of 30 is square root of 3 over 2, and sine of 30 is 1/2. And we can drop the 2, cancels out both of them. We get square root of 3 plus I. Again, real axis, imaginary axis. Write the point in rectangular form. Obviously, in this question, R is 3, theta is 3 power 2. And we know that cosine is 0. Sine of 3 power 2 is negative 1. So we get 3 times I times negative 1. That means negative 3I. Pretty straightforward. So plotting points, going from one format to the next shouldn't be a big deal. Polar, standard form, or rectangular form. Polar, standard form, or rectangular form. Find products and quotients of complex numbers in polar forms, where Z1 is R1 cis theta 1 and Z2 is R2 cis theta 2. And we are saying this is the product, this is the quotient, and of course the denominator Z sub 2 can't be 0. You remember I put that in the summary. We want to look at the proof now. We want to prove that Z1, Z2 is the product of R1, R2, and then cosine of the sum of the arguments I times sine of the sum of the arguments. So what is Z1 times Z2? Replace the Z1 with this and Z2 with this. So Z1, Z2 is this piece, R1 cis theta 1, times this piece, R2 cis theta 2. And all you have to do, distribute. The way we're going to distribute R1 times R2, we put it out and we multiply these two parentheses, everybody. So R1 times R2, we are going to distribute. So again, this R2, we're going to put it here, right? Or just put both of them outside. And now, so cosine theta 1, cosine theta 2. Plus I cosine theta 1 sine theta 2 plus I sine theta 1 cosine theta 2 plus I squared sine theta 1 sine theta 2. So let's write it in this fashion. We are multiplying the two parentheses. We put R1, R2 outside. And we are going to collect terms as follows. If you look at this 2 class, this becomes negative 1 because I squared is negative 1. So you have cosine theta 1, cosine theta 2 minus sine theta 1, sine theta 2. And you put the other two together, you just take out the I. So one more time. When you put these two together, you get cosine theta 1, cosine theta 2 minus, because I squared is minus, sine theta 1, sine theta 2. When you put these two together, you just take the I out. So cosine alpha, cosine beta, minus sine alpha, sine beta. This is cosine of alpha plus beta. So let me just write that. Recall cosine of alpha plus beta is cosine alpha, cosine beta, minus sine alpha, sine beta. So this is cosine of alpha plus beta. That means theta 1 plus theta 2. And sine of alpha plus beta is sine alpha, cosine beta, plus cosine alpha, sine beta. So this is sine of alpha plus beta, means theta 1 plus theta 2. And believe it or not, that's a proof. Therefore, Z1, Z2 is R1, R2, cis theta 1 plus theta 2. So we proved if we are multiplying two numbers in polar format, complex numbers in polar format, we multiply their modulus, their magnitudes, and then cis, we add up their arguments. Okay. So we prove that one, and we are going to prove the quotient. So Z1 over Z2 is R1 cis 1 over R2 cis 2. And to prove that, we are going to multiply by the conjugate of cosine theta 2 plus I sine theta 2, which becomes cosine theta 2 minus I sine theta 2. We're going to multiply and divide by. That is the technique that will do the job. And we are going to distribute this, and we're going to distribute this and simplify. First and foremost, notice the bottom becomes R2. When you multiply these two, is cosine squared theta 2 plus and minus I squared sine theta 2. That's the bottom. And the top, we are going to multiply. I didn't want to do them at the same time so you can see that. So first I want to discuss this. This is plus. This becomes plus 1. And cosine squared and sine squared of the same angle or the same arc is 1. So the parentheses, again, the bottom, R2 times cosine squared of theta 2 plus sine squared of theta 2. That means R sub 2 times 1. That's the bottom. The top, we multiply these two. We get cosine theta 1, cosine theta 2. We multiply these two, we get minus I cosine theta 1, sine theta 2. We multiply these two, we get plus I sine theta 1, cosine theta 2. We are distributing, we are foiling. We multiply these two, we get plus I times minus I, negative I squared sine theta 1, sine theta 2. So this is what we get. We're going to put the first and the last one together. And this minus I squared will change to plus. Okay, everybody, we're going to put these two together. So we have R1 divided by R2 times we are putting these two together, and we're going to put these two together. When we put these two together, this is plus I times this, and this is minus. So notice how we do that. When we put these two together, we take the plus I out. So this remains with this one, and this is minus cosine theta 1, sine theta 2. So again, these two come together. Cosine alpha cosine beta plus sine alpha sine beta. This is cosine of theta 1 minus theta 2. Sine theta 1 cosine theta 2 minus cosine theta 1 sine theta 2. That is sine of theta 1 minus theta 2. And that's the proof. Believe it or not, we just proved it. And z sub 2 can't be 0. You're not responsible for the proof, but if you can follow it, you're in good shape. Okay, everybody. Find product and quotients of complex numbers in polar form. If z is 3 cis 20 and w is 5 cis 100, find their product and their quotient. So to find the product, we use this formula. See how easy it can be done. Just 3 times 5, or 1 times R2, cis 20 plus 100. So it's very simple, everybody, and very straightforward. And we get 15 cis 120. And we don't have to take it to standard form. They didn't ask. If they did, you apply 15 times cosine of 120 plus I sine of 120 to figure out the answer. Okay. All right. What about their quotient? We use this formula. R1 over R2, 3 over 5, cis theta 1 minus theta 2, 20 minus 100. So it's very straightforward, everybody. And so we get 3 over 5 cis 20 minus 100 is negative 80. And you're done with that. But since normally we want it in the first revolution from 0 to 360, we can make this positive by adding a complete revolution, 360 degrees. That gives us 280 degrees. Okay, everybody? So pretty straightforward. And again, if you want it in standard form, you have to expand it. And of course, 280 degrees is not a common arc. Use a calculator to come up with the answer. This one is a common arc and it makes it easy, okay? We want to write 2 cosine of 15 degrees plus I sine of 15 degrees to the power of 4 in standard form A plus BI. Please understand, because it's in polar form, and even if it's not, we bring it to polar form, it makes it very easy to do so. So all we have to do, follow de Moivre's theorem that says if you have z equals r cosine theta or r cis theta, z to the power of n is r to the power of n. So according to this, first of all, z to the power of 4, okay. So 2 to the power of 4, so we are using the exponent 4. So this one to the power of 4 means 2 to the power of 4, and then n theta, 4 times 15, everybody. So 2 to the power of 4, cosine of 15 times 4, I sine of 15 times 4. It's very simple, of course. Everybody knows 2 to the power of 4 is 16. 4 times 15 is 60 degrees. Now, what is cosine of 60? 1/2. What is sine of 60? Square root of 3 over 2. So we should know that. And of course, the 16 goes away with 2 and becomes 8. So we can drop in this manner. We get 8 plus 8 square root of 3i. If we wanted to do this in a standard form, that would have taken a lot longer. And that's the beauty of the de Moivre's theorem and the polar form, everybody. All right, given z equals 1 minus I, find z to the power of 10. Notice, if we want to raise 1 minus I to the power of 10, that means we have to multiply 1 minus I by itself 10 times. It takes a long time to do so. So what do? We put that in polar format, z equals r cis theta. Therefore, we need to find the r and theta. To do so, the modulus or magnitude r is square root of x squared plus y squared. Please understand x is 1, y is negative 1. In essence, you have this format. Okay, everybody? So it's important to understand that this means what? It means x plus iy, okay? That's why we have it as r is square root of x squared plus y squared. And so with that being the case, 1 squared and negative 1 squared, each one is 1. They add up to 2, so square root of 2. What about tan theta is y over x or b over a. So minus 1 over 1. Again, minus 1 over 1. So if tan theta is negative 1, theta is minus pi over 4. Now, if you want to make it positive, remember, just add 2 pi to it. And it becomes 7 pi over 4. It's the same thing. In this case, we just want to go with 1 minus I to the power of 10. We don't have to do that. It's your choice. Again, this is the same as adding 2 pi, which is 8 pi over 4. And it gives you 7 pi over 4. Makes no difference. In any event, z to the power of 10, and z is in the form of RC theta, which makes it square root of 2 times cosine of negative pi over 4 plus I sine of negative pi over 4. Z to the power of 10. According to the Moore's theorem, we have R to the power of n, that means square root of 2 to the power of n. And then we multiply the theta by n, the angle, the arc, okay, theta by 10, in this case, negative pi over 4 times 10. So R to the power of 10, cosine of n theta, n is 10, plus I sine of n theta. So let's multiply those by 10. Let's raise this to the power of 10. To raise this to the power of 10 is the same as raising 2 to the power of 5. And this one is minus 10 pi over 4, which is minus 5 pi over 2. So again, square root of 2 to the power of 10 is the same as 2 to the power of 5. And 10 times minus pi over 4 is minus 10 pi over 4 or minus 5 pi over 2, because 10 and 4 can drop a common factor of 2. So if you want to make them positive, again, just add 2 pi and another 2 pi. It doesn't matter. But this is more than one revolution in negative direction. So first of all, 2 to the power of 5 is 32, and we should know that. Secondly, this one, if we take off 2 pi, in other words, add 2 pi, if I add 2 pi, which is 4 pi over 2, I get negative pi over 2. A cosine of negative pi over 2 or positive pi over 2 happen to be the same, 0. Sine of pi over 2 is positive 1. Sine of negative pi over 2 is negative 1. So the result is 32 times I times negative 1, or negative 32I as the final answer. Therefore, 1 minus I to the power of 10 is negative 32I. And again, if you want to raise this to the power of 10, it takes forever. Write the expression in standard form, a plus bi or x plus y, it means the same thing, okay? And so you want to raise z to the power of 6. You want to raise this one to the power of 6. And we are dealing with a polar form. We don't have to do anything. We just follow this methodology. So r to the power of 6, that means square root of 3 to the power of 6. Cosine of n theta, that means cosine of 6 times theta, which is 10 degrees. So let's just write it as to the power of 6, r to the power of 6 cosine of 6 theta plus I sine of 6 theta. 6 theta. So we are going to raise square root of 3 to the power of 6, and then cosine of 6 times the 10 plus I sine of 6 times 10. Now, square root of 3 to the power of 6, that's the same as 3 cubed. So you have 3 cubed or 27 times cosine of 60 plus I sine of 60. Cosine of 60, 1/2 sine of 60, square root of 3 over 2. And if we distribute the 27, we get 27 times 1/2, which is 27 halves, plus 27 square root of 3 over 2i, or you can put the I first, and this will be your final answer.